Hey everyone, and thank you for joining me here today on this webinar related to optimizing Android mobile workforce performance. So if you're into enterprise mobility management or have a fleet of Android uh, devices out there in your warehouses, in your retail stores, in your branch locations, or even just your employees are using it day to day, we're going to talk about how you can optimize that performance and see ultimately, is Wi-Fi the problem, or is it something else that could be happening to your devices? So just give you a quick introduction to how Android has really become the de facto standard for a lot of different industries that are using those devices and how it's becoming so critical to the business itself. So when you look at a lot of these particular industry segments like retail, logistics, manufacturing, and so on, 80% of the actual employees in the digital workforce are actually what we would call deskless. So they don't sit down and work at a desk all day. They're actually busy doing things, reloading stock and shelves in stores, doing customer service. And this is critical to them that they're able to actually access the applications that make them successful and make them productive. Ultimately, it's a differentiator. And right now, you see that Android has really taken off. There's 72% of mobile devices involved in industry are Android, and this adds up to close to 180 million devices. So the reason is, why is this more popular, for example, than other operating systems like iOS? It's largely because an Android device is extremely customizable. It's an open source operating system, and you can create your own applications, distribute them easily, but you can also integrate them with other systems and solutions that might be already deployed. So imagine point of sales terminals, inventory systems, machines on a manufacturing floor. Android can be easily integrated and is very compatible with the existing infrastructure you already have in your industrial environment. In addition, they're very rugged. They can be put into different form factors quite easily, extremely cost effective for large scale deployment. We see retailers, for example, grocery chains with thousands of locations, and they have to be able to provide devices to all of their workforce. Same thing if you're doing your technician at a telco, installing services at customer locations or in a manufacturing floor. So very cost effective and also friendly with SaaS solutions. They run Chrome browser. They can work with virtually any application for the web, and that allows it to be very easy to deploy applications across the desktop as well as the mobile so that everyone can access the applications the same way. Unfortunately, mobile performance is notorious for problems that pop up and impact the business. So retail, things like transaction delays, customers who are trying to check out, but the Android devices aren't working, trying to fulfill grocery orders remotely for pickup, things like that. Logistics, if you can't get the inventory in real time, you end up with errors and drops your business efficiency. In healthcare, we've all experienced how patient healthcare records and appointment booking and basically managing wait times all comes down to proper communication between employees. And in manufacturing, could actually impact the equipment itself and create production delays. So very costly in terms of cost of poor mobile performance. And ultimately, it's the people using them. The employees can learn to really be frustrated with those devices that are preventing them from getting their job done. And when that happens, you lose morale, and it's something that can really lead to employee churn or looking for a new job. And that's the most expensive impact it can have. While 85% of enterprises will say that mobile devices are critical to business operations, what we've seen is that there is a real problem with the performance side of things. We can manage the devices, the security, and the users for using MDM or EM solutions, but right now, the current statistic is that over half of the employees using Android and mobile devices are experiencing issues every week, and about 23% are experiencing those every single day. So a quarter of your workforce really not getting things done as efficiently as you'd want to. And this is a significant problem. You're talking about an hour per week lost per employee as a minimum. So when you break that down and it's a 40-hour work week, you can see they're losing an entire week per year of productivity per employee using these devices. But nearly 80% of organizations say that they just don't have effective performance monitoring visibility into why these things are happening. So a lot of those problems get either unreported or unresolved. And that can be extremely dangerous from a business productivity perspective, but also from customer sentiment and your brand. So what is causing all these problems in these Android devices in an enterprise environment? I'll take you through the top 5 causes. So we'll start with number 5. Battery life can be impactful and can certainly cause problems if the device is dead during a shift. There's actually much more important ones on the device side. Hardware issues in general. People need to reboot. The Wi-Fi isn't quite connecting properly. There's issues with the screen. There's like a whole bunch of issues that can happen there. That's like number 4 out of 5. Number 3 is application conflicts. So you have 2, 3, 4 applications on those mobile devices and they don't play well together. One of them might be hearing or taking the front stage on the screen and different notifications that might be interrupting another one. And this is especially critical with things, voice services. If you're using Google Voice or Microsoft Teams on a mobile device to allow your employees to communicate together and they're conflicting with other applications, you can lose calls and have quite a few problems there. The application performance itself, of course, is one of the biggest problems. But what's not always obvious when you're looking at a problem when an employee is holding a device and it's not working is whether the application problem is happening because of something on the device, the actual application you install, or is it actually the problem because those applications are connecting to hosts that are allowing them to synchronize data, to exchange data, to really power the application from the remote side. So these are cloud-hosted backends, and you can think of many applications like Microsoft Teams as a good example, where every single call has to go through a cloud location media server that would allow it to connect to other devices. Most of the applications we're using on our phones today, on our Android devices, are connected to servers that allow us to really see performance synchronized across teams, across different users. And ultimately, the biggest problem of all in Android devices is the network connectivity. Now, this is not just Wi-Fi. If you look at the network connectivity path from an enterprise location, let's say this Android device here is in a retail store. Typically, it's going to be connecting to private applications, either SaaS applications or cloud-hosted applications that are private, and it may have a very complex path. It might go through the Wi-Fi in the store, then go through an SD-WAN or potentially direct internet access, go through a cloud access service provider or secure service edge like a Zscaler or a Netscope or a Palo Alto Prisma, and then get routed through the internet, through content delivery networks and all over the place to get to the destination that's actually giving the ultimate performance for the device. So if you can't reach these servers and they can't synchronize, then you can't fulfill grocery orders, you can't do customer service, have calls with your colleagues, you can't update the inventory in real time. So this can be one of the biggest sources of the problems that are typically attributed to Wi-Fi, but actually we're going to look at this a little bit in more depth. And we'll see that actually Wi-Fi is only responsible for a fraction of the issues in the connectivity area. So this is why it's important to have a really good insight into the end-to-end performance. It's a very complex world out there for your apps and your devices to be connecting to. And you can see this is a very representative diagram. But enterprises today, they really have tools that allow them with endpoint mobility management or MDM type solutions to deploy apps, to make sure the devices are up, to configure them, to secure them, to add users, to ensure that mobility is working. But this is really a limited point of view, and that's not really the goal of endpoint mobility management systems, is not to do an end-to-end performance visibility. So it gives you this gap along the entire path of what applications are dependent on, which is really more about understanding how each segment in the network between the app and the application is contributing to the overall performance. So it could be that the Wi-Fi is the issue, or maybe it's the LAN that has a routing loop or some sort of problem. Maybe it's connected to an ISP that has poor connectivity performance, or maybe you're on the mobile network and you're just on the edge of the cell, or you're inside a warehouse or in an office location where there's not very good reception. Zero trust networks, SD-WAN, the cloud networks, all this, and plus the application hosting performance itself is all extremely fundamental to understanding where problems come from, and also to help you not have people work on the wrong root cause. So you might make a hypothesis as to Wi-Fi, you look at all the access points and networks, but actually the problem might be coming from somewhere that's completely outside of your control unless you can have a good conversation with your service provider or your app vendor. So let's take a look at how that looks. If you're in a performance monitoring environment where you really get full visibility across the entire chain, what you'd like to be able to know is, where is the problem coming from that's affecting my users' productivity? Is it happening because of a network issue, an app, or a device? And this is probably the most fundamental one you need to know first to be able to direct that request to the right group within your IT organization so that the problem gets resolved quickly. So you need to understand end-to-end the connectivity, the roaming between Wi-Fi hotspots, but also to failover into LTE or 5G networks, and also be able to understand if the Wi-Fi or device is just down. Just knowing if it's down and why is one thing. Also knowing that if Wi-Fi is performing poorly, but the application is working great, that you don't have to really solve that problem. These are very common problems I'm sure you've all experienced. Extremely difficult to solve without having the ability to really see things from the end user's perspective. And that's why Kadiska has developed an application for Android that actually allows you to see all of this performance directly from the endpoint device. And this is an application that's extremely lightweight, doesn't take any real battery power, and it's running in the background very silently. And there's two ways to deploy this app, and we're going to take a look at it in a minute. But basically, you can put it through your existing MDM or EMM solution, push it to the devices. Or if you wanted to just install it on a few devices, or you want to try it out, then we can go to the Google Play Store. And the process looks something like this, where you do a search for Kadiska. You find that the application, you install that. It loads into your phone pretty quickly. It's a pretty small application, as you can see. There will be some permissions that need to be granted to run in the background, to know the network names, location of cell antennas, and things like that. And then at the bottom here, you can see a button that says, I'd like to add this to my fleet. And a fleet is a group of devices that, for users, that have a common need. So everyone in doing grocery order picking in a store, everyone who's working in a retail location doing customer service, people who are in the office or in a hospital that need to access certain data or certain applications. So it could be groups of people, or it could be a specific site or location. And the way you add this particular device to that fleet, it could be done through MDM, or you just simply click on your camera, look at a QR code through it, and it'll automatically relate you to all the other different devices that are in that logical location. From there, you'll see all the different applications that were configured to be tested to come up on the screen, and you can start to see some data coming in terms of path length, which Wi-Fi network you're in, and the performance. So this gives you an immediate view from all the devices' endpoint perspective into exactly how is that network affecting the application performance, and which segment of that network is doing that, and which network was I connected to when I had problems. And the result of this is that you'll see a really quick improvement in business performance. We can see large-scale deployments of this type of technology reducing trouble ticket resolution times, remediation times from weeks or months that very difficult to troubleshoot down to within a few minutes. And also you'll see that employees can become a lot more productive and won't be telling you that they were unable to get their job done because their device wasn't working. So when you connect to the Kadiska SaaS application, you'll be looking at the network performance area. And here what is the performance accessing specific applications directly from different locations. And these locations could be your office, it could be remote work from home, or they could be Android devices in one of your locations. And let's say they're trying to reach a particular application. You can see we have certain ones here pre-configured, and then you can also add your own. So if I want to see, for example, how Microsoft Teams looked from different locations, maybe there's people in different distribution centers. I'll take a look at North America, and you can get to see all the different sites and what their overall performance would look like. So you can see here that there's an awful lot of problems with Microsoft Teams on the West Coast, and it's a little healthier, a little less packet loss, a little less latency on the East Coast. And then you can go and look into those different, let's say, store locations or distribution centers, and understanding why is there so much latency and packet loss affecting Microsoft Teams from these locations. So this is a very quick view into what that can look like. You can do that for any application or cloud that you're targeting. So let's take a look at what it's the perspective of the fleets. So what is a fleet? It's a group of devices within a specific location that have the app installed, and they're all testing to specific applications of interest. So you can see here very quickly at a glance that our particular fleet here in the Montreal office is looking at the Microsoft applications, the G Suite, HubSpot, our own website, and is telling you the latency and loss to each of those. And we can look at the top sites or the worst sites based on latency, and we can see Microsoft Office is the biggest problem right now. And we can also see the latency over time. So you can see here that users in the fleet in Montreal had a problem with connecting to these applications with over 100 milliseconds of latency, which doesn't sound like a lot, a tenth of a second, but for a voice call, it would completely drop with that kind of performance, or the quality of it would be extremely poor. In this case, we can see just very quickly how this particular location is doing. And we would have a list of different locations if we were in a larger enterprise environment. You can also see what those individual devices are seeing. If I look at a longer period of time, if you're in one location, you can see which devices are accessing which radios. So whether it's Wi-Fi or cellular, the kind of antenna performance they're getting. So no reception, which would tell you that, say, a hotspot is completely down. You can see which networks are offering a very high latency. This is a very high latency and a lot of loss. So you would know that this is one to investigate. And then you can see each individual device and how they're performing, and go really deep into understanding what was the experience that they were having and what was actually causing the problem for application performance. You can also see roaming. So you can see people moving on a specific device or a group of devices from one Wi-Fi network to another. Imagine you're working in logistics and you're working in a distribution center and you're fulfilling a specific order, but then you have to go into the parking lot, or you're the truck driver and you end up leaving and going into a mobile network. This will tell you exactly when that transition happened and what kind of impact that have in terms of either packet loss, latency, and the network path. So you can see how many devices are on each network over time. So this is really interesting, but if you know there's a network problem, how do you really isolate it? That's part of the issues we had. So let's take a look at that. Let's say we're going to test from this one location. We're going to pick off, let's say, Microsoft's couple of media servers. So here we are looking at access to Microsoft's servers that actually are responsible for Microsoft Teams. And you see here a couple of days ago, there was a spike on this media server. So we'll narrow it down to that just to take a look a little closer. And you can see the path here. The path goes through multiple operators or multiple paths to get to the media server. So this one in particular is located in Virginia, and that the office location is in Montreal for Android. And you can see that we're connecting through an ISP here in Ultimate Telecom, which then gets passed off into another segment of theirs, and then it goes into this green network. And this is the Microsoft Cloud network that's connecting us directly to the media server. So it's responsible for a lot of the performance, because everywhere you make a call with Teams, you have to connect to that location. The other one we're coming through is, at some point in time, these Android devices have failed over onto Bell Canada's mobile LTE network. So it also brings you back into the Microsoft network, but through a different path. We can also see that the majority of the traffic here, like 85%, is going through the Wi-Fi, and this is the point Wi-Fi network, the LAN, and then it passes off into the internet service provider. So you can see at any moment how that's happening. I'm focusing on this particular location in time where there was high latency. But if I flip that over to a point where there was much lower latency, you can see that the path has changed a little bit. It's bypassing this particular node and it's going into the network in a different way. But I'm interested in knowing why the Teams calls have failed, or my particular application my employees are using isn't working. So I'll go back to the point where there was trouble, and I'm going to look for where the, let's say, the packet loss or the latency is actually coming from. So if I look at the latency here, it highlights quickly that this link has got a little bit of latency, so it's 7 milliseconds. But as soon as I go into the Microsoft network, I'm getting more significant, more important latency. And this is what's allowing me to help understand where the problems are coming from. At this particular point in time, the real origin of the problem is actually coming from within the Microsoft network. So this is really sweet if you're actually responsible for the Wi-Fi or your SD-WAN or your internet service providers in your company, or even the mobile device. We know here that all the problems that this particular device is having accessing the Teams application or any other application you would use private hosted on your own cloud environment is actually not at all your responsibility. So what do you do with this when you have a problem with Microsoft being an origin? You can pick off the IP address of the routers, you know exactly where they are. You can document this case, you can provide the evidence to them, and you can have them reroute that. And potentially there's a problem with this particular router that seems to be at the middle of all the problems, and they can reset that and create a new kind of experience for your employees very quickly. You can also see over time that if you go a little deeper, and I go generally across Microsoft, that there's a massive amount of different problems in their network. Hopefully, if you're targeting a specific location where it's your own private application, you won't be having that problem. So if I did look at a different application, you'll see that there's quite a different result. So if I go to Microsoft, stay away from Microsoft, let's go to our own application, Condiska's website, or a private application, and we want to see the same kind of detail on that. It would be interesting to know whether we're having the same kind of issues with the same location testing to that one. And you'll see here the path and the route to the Condiska website is completely different, and that there's absolutely no issues with the Wi-Fi. LAN is working very well, and everything seems to be working pretty good. If I wanted to know at this point in time, it's not a lot of problems here, but you can see packet loss and latency at the same time. The same thing here, I could quickly resolve exactly where that is happening from, and if it's part of the active route. So this one here is actually outside the active route, and the latency is well distributed across different layers right now. There's a little bit inside my LAN here, 12 milliseconds, but nothing that's going to impact our users. So very quickly, you can see exactly where to focus, and you can also see if the network is not the problem for an application that might be glitching. I invite you to try this out. It's very easy to download that from the Google Play Store and ask for a free trial here on condiska.com/try, and then we'll set that up for you very quickly. You can test it out and see how your devices are performing in your environment and get all the statistics over time and by all the locations, so you can understand how to optimize that experience for your mobile-centric workforce.